Hi students, Mrs. Sims here. Yesterday we talked about adding and subtracting with scientific notation. Today we're going to talk about multiplying and dividing. So have out your note packet that has this paper in it, multiplying and dividing with scientific notation. The rules are pretty simple. So once you have your paper, let's get started. When you're multiplying, because of the commutative property, you can multiply numbers in any order. So the easiest thing to do when you have numbers that are in scientific notation is to split them up, like numbers times numbers and exponent in base times exponent in base, so that you can multiply easier. So for example, it says to multiply values in scientific notation, rearrange the multiplication problem and apply the laws of exponents. So for example, we've got 4.5 times 10 to the 5th times 2 times 10 to the 3rd. So you can multiply numbers in any order. So it would be easier to just do 4.5 times 2, so numbers times numbers, and then 10 to the 5th times 10 to the 3rd. So the numbers get multiplied together, so 4.5 times 2 is just 9. And then we use our laws of exponents, 10 to the 5th times 10 to the 3rd. Remember, the product rule says that when exponents are being multiplied, you actually add them. So that becomes 10 to the 8th. So we have 9 times 10 to the 8th. Same thing when you divide. You can put them in any order. So if we have 8 times 10 to the 6th divided by 4 times 10 to the 3rd, it would be much easier to just do 8 divided by 4 and 10 to the 6th divided by 10 to the 3rd. So 8 to the 4, or 8 divided by 4 is 2, and then 10 to the 6th divided by 10 to the 3rd. Remember, that quotient rule tells you to subtract. So 6 minus 3 is 10 to the 3rd. So that answer would be 2 times 10 to the 3rd. So if you split them up and put numbers with numbers and exponents with exponents, then it's going to make it a lot easier. So for example, number 1, we have 3 times 10 to the 4th times 7.2 times 10 to the 2nd. So again, let's do numbers times numbers. So 3 times 7.2, that's going to be 21.6. And then let's do exponents. 10 to the 4th times 10 to the 2nd. So 10 to the 4th times 10 to the 2nd is going to be 10 to the 6th. So the scientific notation answer is we have 21.6 times 10 to the 6th. Remember, we cannot have, in scientific notation, you can't have a number 10 or greater. You want a single digit. So I'm actually going to move that over, which is going to change that as well. So in scientific notation, it would be 2.16 times 10, because I had to move that over one place. We now have to the 7th. Standard form, I would write 216. That's 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Yep. So 21,600,000 is the answer to that one. So same thing. Let's do, actually, I'm going to save number 2. Let's do number 3 together. So the same rules apply. It's going to be easiest to just do 9 divided by 3. 9 divided by 3 is just 3. And it's going to be easiest to keep these together. 10 to the 9th divided by 10 to the 7th. So we end up subtracting, and those become 10 to the 2nd. So we don't have to convert anything there because 3 times 10 to the 2nd is acceptable for scientific notation. When we write that in standard form, that just means 3, and then you move it over 2 places, which is 300. Okay, I want you to try number 2 and number 4. So pause the video and do number 2 and number 4 on your own. Okay, hopefully you had a chance to do those on your own. Let's see what you got. So we're going to multiply 1.5 times 5 just to start. So 1.5 times 5 is 7.5. So the number is 7.5. And then our exponents, we have 10 to the, let's say 5th, I wrote on it. 10 to the 5th, yep, times 10 to the 3rd. So 10 to the 5th times 10 to the 3rd becomes 10 to the 8th. When you write that out in standard form, 7, 5. So that's 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. So 750 million should be your answer in standard form. Okay, for the next one, we're going to do 9.45 divided by 2.1. 9.45 divided by 2.1 gives me 4.5. So 4.5 is the number. And then to think about our exponents, we've got 10 to the 7th divided by 10 to the 2nd. So those get subtracted and become 10 to the 5th. So when I write that out, it's going to be 4. 5 is 1, 2, 3, 4, 5. So 450,000. Okay. When we move on to the back, these have a combination of numbers written in standard form and scientific notation. So you're going to want to start by converting to standard form. So I would want to put a decimal in between the 1 and the 2 so that that number is going to become 1.2 times 10. And then I'm going to move it back 1, 2, 3, 4, 5 to the negative 5th. And that's getting multiplied by 6 times 10 to the negative 2nd. So again, our numbers get multiplied. 6 times 1.2 is going to give me 7.2. So 7.2 is the number. And then our exponents, 10 to the negative 5th times 10 to the negative 2nd becomes 10 to the negative 7th. If I write that one out, 7, 2, that's back 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep. So 0.0000072. Okay, let's go ahead and do number 7 together. First, I need to convert this one to scientific notation. So I'm going to put a decimal there. So the top is going to stay 6 times 10 to the negative 3rd. The bottom is going to become 3 times 10 to the 1, 2, 3, 4, 5, negative 5th. So keep the numbers separate from the exponents. We're going to divide 6 and 3. That gives me 2. And then for our exponents, we've got 10 to the negative 3rd divided by 10 to the negative 5th. So remember, those get subtracted. So negative 3 minus negative 5th, negative 5. When you subtract a negative like that, it becomes a giant plus. So that's really 10 to the 2nd. So 2 times 10 to the 2nd is going to be 200. Okay, I want you to pause the video and do number 6 and do number 8. Okay, so for number 6, I went ahead and rewrote the 7.3 times 10 to the negative 1 was good, but I rewrote the 0.004 to be 4 times 10 to the negative 3rd. So we're going to start by multiplying numbers. 7.3 times 4 is 29.2. So we have 29.2. And then 10 to the negative 1 times 10 to the negative 3 becomes times 10 to the negative 4. So that's not a great way to write that in scientific notation. I really need my decimal to be between the 2 and the 9. So it should be 2.92 times 10. Because I moved it over 1 to the left, I only have to go back 3 now. So that's 2.92 times 10 to the negative 3rd. So 1, 2, 3. So it should be like that. 1, 2, 3. So 0.00292. Okay, for 8, I rewrote the numerator in scientific notation. So that becomes 9.6 times 10 to the negative 4th. And then I'm just going to worry about the numbers first. So I'm going to take 9.6 and divide by 1.2. So 9.6 divided by 1.2 is going to be 8. And then 10 to the negative 4th divided by 10 to the negative 8th. Remember, those exponents get subtracted. When you subtract a negative, you end up adding a positive. So that becomes negative 4 plus 8. So that's times 10 to the 4th. So 8 and then 1, 2, 3, 4. 1, 2, 3, 4. Yeah. 80,000. Okay. For the two word problems, you are going to want to probably put them both into scientific notation and do the operations. So go ahead and pause the video and do 9 and 10. Okay, for number 9, I went ahead and put them both in scientific notation. So the NBA player's salary is on the numerator, 2.5 times 10 to the 7th, and John's starting salary of $40,000 a year is on the denominator, 4 times 10 to the 4th. So if we're dividing that, 2.5 divided by 4 is the first thing I would do, and that is 0.625. And then 10 to the 7th divided by 10 to the 4th, we subtract, is 10 to the 3rd. So that's not a great way to write it in scientific notation. So I'm going to go ahead and just convert that. So if I'm moving this over 1, 2, 3 places, that is basically 625. So he makes the NBA player makes 625 times more money. If I write that in scientific notation, that's going to be 6.25 times 10 to the 2nd, because I don't want to leave 0.625 in scientific notation. So I want to make my scientific notation correct in that answer. Okay, for number 10, I'm just going to make them numbers. If Kelly's heart beats an average of 1 times 10 to the 2nd, well, 1 times 10 to the 2nd is just 100. So we're saying that her heart beats an average of 100 times every minute. How many times does it beat in a year? And they tell us 1 year is 525,600 minutes. So if we multiply that by 100, that's just going to add 2 zeros to that number. So with the 525,600 and add 2 more zeros. So 1, 2, 3, 1, 2, 3. So that's basically 52,560,000 times. If I then change that to scientific, 5.256 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Okay, you have practice today. That is multiplying and dividing. Please refer back to your notes. Do the best you can, and I will see you soon. Good luck.